Hello, welcome back. We're going to talk about electrochemistry today. And for electrochemistry, let me bring you back way to the first semester chemistry when you were learning about oxidation states. I have the rules on how to assign oxidation states here for your reference, and then the chart on the right after rule number 5. So if you are having a hard time, please review that section of the textbook. And remember, these rules are hierarchical, meaning that rule 1 is more important than rule 2 and then rule 3. And also in that chart here, fluorine, hydrogen, oxygen, that's hierarchical as well. So how to balance redox reactions. First thing is to assign oxidation states. Write and balance the half reactions for the electron. Balance the oxygens with waters, balance the H's with H+. And then if it's then you're done for an acidic reaction for the alkaline neutralized with hydroxide. I'm going to do it a different way than the book. The book likes to go through and balances all the half reactions. I like to include that in with the main reaction. But okay, I will show you how to do this. So what is the redox equation here? Aluminum plus copper makes aluminum plus 3 in copper metal. So if you look at this, you're like, oh, it's already balanced, right? Not entirely, because our half reaction here is aluminum goes to aluminum plus 3 and generates 3 electrons. And copper plus 2 consumes 2 electrons to form copper metal. So these two are our half reactions. So this shows us where the electrons are going. And we have 3 and 2. So what you do then is you balance them with the lowest common denominator. 2 and 3 are both prime numbers, so you have to multiply them. So it's going to be 2 of this and 3 of this. And you do that because the aluminum is going to generate 6 electrons. So 2 aluminums will generate 6 electrons, and 3 coppers will consume 6 electrons. So electrons can't just be freely hanging out. So then you go to the top and you balance it like this. And like I said, the 2 aluminums are going to generate 3 electrons, and the coppers are going to consume. The 2 aluminums will generate 6 electrons, and the 3 coppers will consume 6 electrons. So let's see if you can solve this one. So pause it if you want. If not, here is the half reaction. It's going to be 2H plus 2 electrons yields H2, because hydrogen is a free element that's got all its electrons, and chromium goes to chromium plus 3 plus 2 plus 3 chromium plus 3 electrons. And we have 2 and 3, so this is going to be 3, and this one's going to be 2. So then you have 6, 2, 3, 2, like so. Okay. All right. Something a little more difficult. Balance this reaction: iron plus 2 going to permanganate iron, or plus permanganate going to iron plus 3 and manganese plus 2. So it's really easy to figure out the oxidation states for iron and magnesium, and as they're monatomic ions, they're plus 2 for iron plus 2, plus 3 for iron plus 3, and plus 2 for manganese plus 2. What about for permanganate? We use the rule -1 equals manganese oxidation number plus 4 times oxygen's oxidation number. Oxygen tends to be -2 as per the chart. You can review this. -1 is manganese plus a -8. 7 equals manganese. So this one is plus 7. So we need 5 electrons to go from plus 7 to plus 2. And so that's what the oxidation state means. It means manganese is losing 7 electrons. So it needs 5 electrons to go to the plus 2 state. So iron plus 2 goes to iron plus 3 plus an electron. So an electron are generated. So you need to multiply the top equation by 5. So 5 electrons need to be generated and 5 electrons consumed. So we put 5s here like this. So the next step is we need to, we're at 5 irons here. We need to balance the oxygens. So there are 4 oxygens on the left, so we need to add 4 waters on the right. So now we have the oxygens balanced, and the thing is we don't have the hydrogens balanced, so there are 8 hydrogens on the right, so we need to put 8 H pluses on the left. So now we're balanced. So we have everything balanced now. We have the electrons balanced, we have the oxygens balanced by using waters, and we have the hydrogens balanced using the H pluses. Okay? So why don't you try it with this one? So our half reactions are still just learn the manganese plus 7 plus 5 electrons goes to manganese plus 2, and then aluminum goes to aluminum plus 3 electrons. So we need to have 3 and 5 are both prime numbers, so we have to use them both. So let's look at the number of oxygens. There's 12 oxygens on the right, so we need 12 waters on, 12 oxygens on the left, so we need 12 waters on the right. And there's 24 hydrogens, so we need 24 hydrogens there like that. Okay? So that's how you balance that one. What about a basic solution? So we've already learned this is plus 7. Manganese here, MnO2, so MnO2, 0 is manganese plus 2 times oxygens. Oxygen tends to be minus 2, 0 is manganese plus 2 times minus 2. 4 is equal to manganese, so this is plus 4. So MnO4 minus plus 3 electrons goes to MnO2. So plus 7 plus 4, we need to consume 3 electrons. And also 2I minus goes to I2 plus 2 electrons. So 3 and 2 again, so we need to multiply the first one by 2, second one by 3, because the lowest common denominator is 6. So we have 6I minus plus 2 permanganate makes 3 iodines and 2 manganese oxides. So we have to balance the number of oxygens, right? So we have 2 times 4, 8 oxygens on the left, 2 times 4, 8 oxygens on the left, and we have 2 times 2. We have 4 oxygens on the right, so we need 4 waters on the left to balance out those oxygens. And if we have 8 hydrogens, we need 8 hydrogens here. Now the thing is, this is a basic solution. So what we need to do now is we need to add 8 OH minuses here. Okay, so this equation, we're going to add 8, oh shoot, didn't copy. We need to add 8 OHs. So the 8 OHs here, we're going to have, so plus 8 OH minus, and then the 8 OH minus and the 8, I can write this out, the 8 OH minus plus 8 H pluses, this is going to form 8 H2Os. So this side here is going to react and form 8 H2Os. Now we have H2Os on both sides of the equation. So I'll just go ahead and copy this. So I went ahead and pasted that there. So we've got, I'll change this. We have the 4 waters here and 8 waters here. So what we can do is we can get rid of 4 of the waters like so. And so now this is the overall equation. So this is the basic solution. 4 waters plus iodide plus, oh, I'm sorry, I didn't put the numbers here. I was just copying. Four waters plus 6 iodide makes 2 permanganate, plus 3 iodines and 2 magnesium oxides, and generates 8 hydroxide. So that's in basic solution. Okay. So usually what my students like in the classroom, they like to see me do it a few times, and once you get a hang of it, it's not that hard. At least I don't think it's hard. I think it's actually kind of fun. I always have a good time doing these. So if you want to watch me do them real fast, so for A here, iodide plus NO2 minus goes to I2 plus NO. So let's do the oxidation states. Nitrogen here is plus 2, iodine 0, minus 1. So nitrogen, so here minus 1 is nitrogen plus 2 times oxygen's oxidation state. Minus 1 is nitrogen plus 2 times minus 2. So 3 is nitrogen, so this is plus 3. So this means that NO2 plus electron makes NO, and we have 2I minus goes to I2 plus 2 electrons. So we need to multiply the top one by 2. So we have 2 up there, and there is 4 waters on the left, and I'm sorry, 4 oxygens on the left and 2 oxygens on the right. So we need 2 waters to balance that out, and that means we need 4 hydrogens on this side like that. So these are fun, aren't they? I think they're fun. Okay, ClO4 minus plus Cl minus makes ClO3 minus Cl2. So that's minus 1, that's 0. And then ClO4 minus, so ClO4 minus, okay, so minus 1 is going to be chlorines plus 4 times oxygen. Minus 1 is chlorine plus 4 times minus 2. 7 is chlorines. And then ClO3 minus 1 is chlorine plus, oh shoot, not 4, 3. 3 oxygens minus 1 is chlorine plus 3 times minus 2. 5 is chlorine. So that means our half reactions, so we have ClO4 minus plus Cl minus makes ClO3 minus plus Cl2. And our half reactions are 2Cl minus goes to Cl2 plus 2 electrons. And we have then ClO4 plus 2 electrons makes ClO3 minus. So that's great. 2 and 2, lowest common denominator is 2, so it's balanced there. And there's 4 oxygens on the left, so we need a water on the right, and then we need 2 hydrogens on the left, and it's balanced. All right, and the last one then. So NO3 minus NO, so this is going to be plus 2 there, and NO3 minus, this is going to be plus 5. If you want to go through, it's minus 1 is nitrogens plus 3 times oxygen, minus 1 is nitrogen plus 3 times minus 2, 5 is nitrogen, okay? So we have NO3 minus plus 10 plus 2 goes to 10 plus 4 plus NO. So we have NO3 minus going to NO, so we need 3 electrons for that, right? Plus 5 to plus 2. And then 10 plus 2 goes to 10 plus 4 plus 2 electrons. So we need to multiply the top one by 2 and the bottom one by 3. So this is 2, 3, 3, 2. And there are 6 oxygens on the left and 2 on the right, so we need 4 waters. And then 8 H pluses over there. So, see, once you get a hang of it, they're actually kind of fun. They're little puzzles. Don't think of this like chemistry work. Think of them as puzzles, and I like solving puzzles. They're fun. Okay, so hopefully this has been a primer for you, and hopefully a review for the oxidation states. This is important because we're going to talk about how this applies to batteries. We're going to talk about much of electrochemistry is dealing with batteries, and different electrochemical reactions have different things, have different equations. So we will talk about that in the next class. So ta-ta for now.